Welcome to Module 13, ICMP. Frame it with the on-screen line. A stalled model train shows you exactly where the problem is, but a network doesn't, unless you have the right tools. ICMP is that tool. This module ties together everything from IP addressing into practical troubleshooting. Objective: use various tools to test network connectivity. Preview the topic table. ICMP messages themselves, then ping and traceroute testing. This is a shorter, very practical module. The payoff for all the addressing theory from modules 8 through 12 is finally being able to actually test and troubleshoot a network. IP is best effort, but ICMP fills the gap by providing error and informational feedback. Crucially, its purpose is not to make IP reliable, just to report problems. ICMP messages aren't required and are often blocked for security reasons, worth flagging early since it explains some confusing troubleshooting scenarios later. ICMP v4 serves IPv4, ICMP v6 serves IPv6 plus extra functionality. This course uses ICMP loosely to mean both. 3 message types are common to both versions, covered next. Host reachability uses the ICMP echo request/echo reply exchange. This exact mechanism is literally what the ping utility is built on. Walk the two-way exchange on screen. Source sends echo request, destination replies with echo reply if reachable. Simple but foundational. Everything else in ping testing builds on this. When a packet can't be delivered, the host or gateway sends back a destination unreachable message with a specific code explaining why. Walk the code table on screen. ICMP v4 codes, net/host/protocol/port unreachable, versus ICMP v6 is similar but not identical codes. No route, administratively prohibited, beyond scope, address/port unreachable. Point out these codes are what shows up in real troubleshooting output. Time exceeded fires when a router can't forward a packet because its TTL IPv4 or hop limit IPv6 hit 0. The router discards the packet and reports back to the source. This exact mechanism, packets deliberately expiring hop by hop, is what traceroute is entirely built on, which gets its own deep dive later in the module. Worth flagging that connection now so it clicks later. ICMP v6 mirrors ICMP v4's core messages but adds 4 new neighbor discovery protocols shown in the 2 categories on screen. Router-to-device messaging, RS/RA, enabling dynamic address allocation, and device-to-device messaging, NS/NA, handling address resolution and duplicate detection. Also mention, ICMP v6-ND includes a redirect message, functioning similarly to ICMP v4's redirect. Routers send RA messages every 200 seconds to every IPv6 host, carrying the prefix, prefix length, DNS address, and domain name. Walk the plain English translation on screen. Use SLAAC. Here's your prefix, here's your default gateway. ASLAAC host sets its default gateway straight from this message's link local address. A host doesn't have to wait up to 200 seconds for the next scheduled RA. It can request one immediately with an RS message, typically sent right after booting up. Walk the 2-step exchange on screen. PC1's RS, asking if a router is present, followed by R1's RA reply. This is the same RS/RA process introduced back in Module 12, now shown as an ICMP message type specifically. NS and NA handle address resolution, IPv6's equivalent of ARP. When a device knows an IPv6 address but not the MAC, it sends an NS to the solicited node multicast address. The owning device replies with an NA containing its MAC. Walk the plain English exchange on screen. Same pattern established back in Module 9's ARP discussion, just with different message names. NS/NA also handles duplicate address detection. Before finalizing a new address, a device can send an NS targeting its own new address. If an NA comes back, someone else already has that address. Conflict. If nothing replies, the address is confirmed unique and safe to use. Note on screen. DAD isn't strictly required, but RFC 4861 recommends it for unicast addresses. Ping works on both IPv4 and IPv6 using echo request/reply to test connectivity, reporting round-trip time as a rough performance indicator. Worth flagging. The very first ping often times out simply because address resolution, ARP or ND, hasn't happened yet. Not necessarily a real problem. 3 standard ping targets previewed on screen. Loopback, test the local stack. Default gateway, test the local network. And a remote host, test the whole path. Each gets its own slide next. Pinging a loopback, 127.0.0.1 for IPv4, 1 for IPv6, tests a host's own internal IP stack. The ping never actually leaves the device, shown in the looping arrow diagram. Important limitation to stress. A successful loopback ping only confirms IP itself is installed and working. It says nothing about whether addresses, masks, or gateways are configured correctly, and nothing about lower layers. Pinging the default gateway tests whether a host can reach its own local network. Success confirms both the host and the gateway router interface are operational. Useful troubleshooting logic. If the gateway doesn't respond but another local host does, the problem is likely the gateway address configured on the host itself, or a security setting blocking ping on the router. Pinging a remote host tests connectivity across the entire path. Success confirms the local network, the default gateway, and every router in between, plus the remote host itself, are all working. Important caveat. Many admins block or limit ICMP entering their network, so a failed ping here doesn't always mean a real problem. Could just be a security policy in effect. Ping confirms connectivity, but says nothing about what's in between. That's traceroute's job, listing every hop successfully reached along the path. If the trace fails partway, the last responding router shows roughly where the problem, or a security restriction, lives. Traceroute also reports round-trip time per hop, with an asterisk marking a lost packet. Repeated loss or high times at one hop can point to a stressed router or link. The on-screen line sums it up. Ping tells you if it works, traceroute tells you where it breaks. Traceroute is a clever reuse of the exact TTL/hop limit mechanism from the time exceeded slide earlier. Walk the three-step process on screen. First packet sent with TTL equals 1, expires at the very first router, which replies time exceeded, giving traceroute hop 1's address. Each subsequent round increments TTL by 1, expiring 1 hop further each time. When the final destination is reached, it replies with echo reply, or port unreachable instead of time exceeded, completing the trace. Close the module walking each bullet. ICMP provides feedback, doesn't guarantee reliability, and isn't always allowed. The 3 shared message types: reachability, unreachable, time exceeded. ICMPv6's 4 ND editions, RSRA, NSNA, pings 3 test targets: loopback, gateway, remote host, and traceroute's TTL incrementing mechanism for mapping the full path. Reinforce the closing distinction. Ping tells you whether it works. Traceroute tells you where it breaks.